What if the secret to stopping, that massive 3 p.m. sugar crash isn't brewing another pot of coffee, but drinking a shot of sour, murky, fermented apple juice right before you eat a bowl of pasta?
I mean, it sounds like a terrible dare.
Right.
But looking at the stack of research we're going through today, there's actually some really fascinating biology backing that up.
Yeah. So, welcome to today's deep dive. We are looking at the systemic mechanics of organic, unfiltered apple cider vinegar, or ACV.
And our goal for you listening is to completely bypass the wellness jargon.
Exactly. We want to look under the hood at the actual biological mechanisms. Like, how does this stuff physically alter your digestion and metabolism at a cellular level?
And to do that, well, we have to talk about the weirdest part of unfiltered ACV.
Oh, you mean the cloudy web floating at the bottom of the bottle?
Yeah, the stuff they call a mother.
Honestly, it looks a bit like pond water.
It really does. But biologically, that sediment is a bioactive biofilm.
A biofilm.
Yeah, essentially it's a living matrix of cellulose, beneficial bacteria, and enzymes tightly woven together.
Yeah.
It's not just leftover apple mush.
Right.
It's a self-sustaining ecosystem that's constantly producing live cultures.
So it's essentially like a microscopic factory just brewing active ingredients right there on the shelf.
Exactly.
And looking at these notes, the heavy hitter it produces is acetic acid.
Yeah, that is the compound driving almost everything we're talking about today.
Okay.
Because acetic acid fundamentally changes how your body handles energy, specifically by slowing down gastric emptying.
Wait, hold on. If I just ate a massive plate of carbohydrates, how can a tiny splash of acetic acid possibly slow down that entire digestive process?
Whoa.
I mean, is it just diluting the food?
No, not at all. It's actually an enzymatic reaction. Acetic acid temporarily suppresses the specific enzymes in your stomach and small intestine that break down starches.
Oh, wow.
Yeah, so because those starches aren't breaking down as fast, your stomach holds on to the meal longer.
So instead of all those carbs flooding the bloodstream at once and causing a huge glucose spike,
Exactly.
the acetic acid acts like a bouncer at a club, only letting a few glucose molecules pass the velvet rope at a time.
That is the mechanism in a nutshell, yeah. By metering out that glucose slowly, your body doesn't need to pump out massive amounts of insulin.
Right. So you maintain a steady, aligned energy state instead of dealing with that inevitable crash.
Spot on.
But I know people listening are probably thinking, wait, I already get heartburn or indigestion.
Oh, sure.
Why on earth would I add more acid to my stomach? Doesn't that just make the fire worse?
It's a completely logical fear, but digestion actually requires a highly acidic environment to function.
Right.
When your stomach pH isn't acidic enough, the valve at the top of your stomach doesn't close properly.
Which is often what causes that reflux, right?
Exactly. Acetic acid helps drop the stomach pH to its optimal level, meaning proteins break down efficiently without your system having to overwork or overcompensate.
Okay, yeah, that makes perfect sense. It's setting the right baseline. But these notes also talk about a dual role with gut microbes.
Yes.
The enzymes from the mother add beneficial bacteria, but the acetic acid acts as an antimicrobial. So how can it kill bacteria while also supporting it?
It comes down to cellular structure. Acetic acid is a short-chain fatty acid, so it can physically pass right through the cell membranes of opportunistic pathogens.
Oh, so it gets right inside them.
Right, and once inside, it lowers the internal pH of those bad bacteria, effectively dismantling them from the inside out.
Wow. But what about the good stuff?
Well, beneficial gut bacteria have evolved over millions of years to tolerate and even thrive in that slightly acidic environment.
It's like a smart security system or, I don't know, a specialized weed killer that somehow acts as fertilizer for the grass.
That's a great way to put it.
Yeah.
And the effects of that optimized gut environment don't stop at digestion.
What do you mean?
Those short-chain fatty acids physically cross the blood-brain barrier.
Wait, really? We're talking about a direct physical communication line between the stomach and the brain.
Yeah, they interact with specific receptors in the brain that regulate appetite.
Oh, fascinating.
When acetic acid hits those receptors, it triggers the release of satiety hormones. It essentially tells your brain, hey, we have enough energy. You can stop feeling hungry now.
So instead of trying to white-knuckle your way through a diet, this actually creates an internal agreement between your actual nutritional needs and the physical craving to eat.
Exactly.
It bridges that disconnect we feel when we're full but still want to keep snacking.
It replaces a battle of willpower with natural chemical signaling.
Right. So for you listening, understanding this means realizing that optimizing your gastric pH and balancing your microbiome isn't about harsh, restrictive diets.
Not at all.
It's about naturally aligning your energy levels and hunger signals through simple chemistry.
Which leaves us with a pretty interesting question.
Oh,
Yeah. If a simple compound like acetic acid can act as a targeted antimicrobial and a direct communication bridge between your gut and brain.
what other common dietary acids might be quietly orchestrating your biological alignment right now, completely under the radar?
Exactly. Something to mull over until next time.